This is a short video that's going to show you how to graph the data from the baking soda and vinegar experiment. So what you can see here is that I've created the table in Excel that should be identical to the data table that you have in your lab notebook. And what you'll see is the first column is the mass of baking soda, and I've highlighted that in yellow because it's one of the things that we're going to be graphing. It's going to be your X variable. And then columns 2, 3, and 4 is data that you gathered, but you're not going to have to graph that data. And then the last column, the mass of carbon dioxide produced, is the data that is ultimately going to become your Y data set. But as is explained in the directions, we actually need to graph this as two separate series. So what you can see here in pink is this is the data where I decided that the baking soda was the limiting reactant. So the baking soda limited how much carbon dioxide was produced. And then in blue, I highlighted the data where I felt like the acetic acid was the limiting reactant, or the acetic acid was limiting how much carbon dioxide could be produced. So I have reordered that data down here. So Excel likes you to have your X variable data in the leftmost column, and then your Y variable data sets you can have any number of columns to the right. And so what I've made is my first data series is the pink data from up above. It's the same thing. And this is the data that is baking soda limited. So I will highlight that a blue color. And my next data series is where my acetic acid was limiting how much carbon dioxide I could produce. So I'll highlight that in red just so you can see the difference. And what we want to do is we want to graph this data all in one graph. So to do that, all I have to do is highlight my X variable data with my two Y variable data sets, and I'll go to Insert. I'm going to pick a chart. It's a scatter chart. I almost always want a scatter chart. Put it right here. And I'm going to delete my legend because I'm not going to need it. And so your instructions say that you're going to need to add a trend line. So let's add all the different things we're going to need. We're going to need axes titles, and we're also going to need a trend line. And we want the trend line for series 1 only. And also on trend line, we want to go to more options. And what we want to do is we want to display the equation on the chart, and we want to display the R squared value on the chart. So I'll close this. We'll make a title. We will label our y-axis, which is the mass CO2 produced. And we'll also label our x-axis, which is the mass of baking soda. And here's our equation. I'm just going to move this over. And I also want to format my y-axis. And what I want to do is format the vertical axis value so that the maximum is something a little lower. And we can close this. Okay, so now what you can see is that we have our first data series that we fitted with the trend line, and then we have our last 3 points. And what you can see here is that, it didn't matter how much baking soda we had, whether we had 0.9 grams, looks like about 1.2 grams or 1.6 grams, we produced about the same amount of carbon dioxide, and that's because we were limited by the amount of vinegar we had. So it didn't matter how much more baking soda we added to the flask, the amount of vinegar was limiting how much carbon dioxide we could produce. So the next step is to calculate the average mass of carbon dioxide for the vinegar limited trials, and you can do that right in Excel. You just need an equal sign to enter a formula. Use the function average And that is the average mass of carbon dioxide for our last 3 trials. So the next step is to calculate the predicted mass of baking soda needed to fully react with 10 milliliters of vinegar. And what that means is, here on the graph you can see that as my mass of baking soda increased, my mass of carbon dioxide also increased, and there was a linear relationship between the two variables. Now, at some point, and it's probably going to be someplace right around here, the mass of carbon dioxide produced levels out. And what we want to find out is, what is this point? What is the value of the mass of baking soda when the mass of carbon dioxide produced is right around here, around 0.4 grams, or we actually have our average value of 0.398 grams. So if we're looking at the graph, we can look at it and say, okay, it looks like it's going to be somewhere around maybe 0.79 grams, but we can, of course, can be exact by solving this equation for X, which is our mass of baking soda. So all we need to do is say, plug in a Y value of 0.398 into this equation here. So I can do that right here in Excel. So I'm just adding the intercept to 0.398, and I'll divide by the slope. So you can see that the mass of baking soda was actually 0.790, which is what we determined by just visual inspection of the graph. So the other thing that you're going to have to do is you're going to calculate the theoretical mass of baking soda needed to fully react with the vinegar, and you'll calculate a percent error.